We're going to start with review, because Friday wasn't a long time ago, and then we're going to go back and do a couple new things. So the first thing is to find the domain and x-intercepts. So for rational functions, you have to exclude real numbers that make the denominator 0. So does this x squared plus 4, does that equal 0 ever for real numbers? No. So not true for real numbers. If you had to solve that equation, you'd get x squared equals negative 4, and x equals plus or minus 2i, right? Okay, but it's not real numbers. So in this case, that means the domain is all real numbers, so use that R symbol, or you can say negative infinity to infinity. You can plug any number you want to in there. Okay. How about x-intercepts? How do you find x-intercepts? Before you factor, what do? You set y to 0. Because you need to have that idea that whenever I find an x-intercept, I set y to 0. That's what you do. So 0 equals x squared plus 4x minus 5 over x squared plus 4. I apologize that there's not a whole ton of space there. Now with these rational functions, something kind of nice happens. When you multiply both sides by x squared plus 4, it just goes poof, right? 0 times anything is 0, including things that have x's in them. So 0 equals x squared plus 4x minus 5. And do you see why Cole was saying factor? Yeah, okay. So how does x squared plus 4x minus 5 factor? X plus 5, x minus 1. So where are the x-intercepts? Good morning.
5 and 1.
X equals negative 5 and 1. Technically, they're the points negative 5, 0, and 1, 0. So you could plot those on the x-axis as soon as I have to start at what your graph looks like. You'd know something.
If this was on a test, would you want us to write it in coordinate form?
I'd have to be pretty explicit that I would wanted that from you. I'd just say, like, put your, x-intercepts as ordered pairs. Otherwise, you could just say either way. But I'd prefer, I don't know, I think Alex just requires you to write it as a number, right? Yeah, so, okay. Alrighty, next one, so idea. So find the domain. Are there actually going to be numbers to leave out this time? Yes. So the numbers you can't plug in are the ones that make your denominator 0. Does x squared minus 25 factor?
Yes.
Yes, what does it factor into? X plus 5, x minus 5. So your x cannot equal what two numbers?
5 and negative.
Plus minus 5. And on your test, I'm going to make you write everything as intervals. Let's just give me an interval. So everything from negative infinity up until what's the first number you leave out?
Negative 5.
Negative 5. And because you leave it out, you put a parenthesis around it. That's how you say I've left it out. Union parenthesis on that side too, so you leave it out there as well. Negative 5, and you're all good up until what number?
5.
5. And then you're all good from 5 on. Now for x-intercepts, you're going to solve 0 equals x to the 4th plus x squared plus 1 over the denominator. And you end up with 0 equals x to the 4th plus x squared plus 1. And if I expect you to do this reasoning, I'm going to make it pretty obvious. Will that expression ever equal 0? Why or why not?
It doesn't equal 0 because they're both even powers. So
Both-
it'll always equal a positive number.
Does that make sense, guys? Both of those powers are even. So if you take positive numbers and plug them in, you're going to get some positive thing, right? If you take negative numbers and plug them in, you get some negative thing, right? What happens when you plug in 0? Or you get some positive thing as well because you square them first, right? And then you add 1 to it. So this has no solution,
No x-intercepts.
which means there are no x-intercepts. if I'd given you like x to the third plus x squared plus 1, that's actually not obvious if that has x-intercepts or not. So what I mean by making it obvious is the powers will probably both be even and you're adding a positive number. We could theoretically factor some stuff like that, right? But this one doesn't actually factor. It's x to the fourth plus 1x squared. If it was plus 2x squared, it could factor. Okay. We also talked about how to find vertical and horizontal asymptotes. So how do you find vertical asymptotes and how do you find horizontal asymptotes? So when do vertical asymptotes happen? When the denominator equals 0, and technically that's after any simplifying. This one doesn't have that thing, but denominator equals 0. Horizontal asymptotes are a little bit harder to say really succinctly, but what do you think? What do you want to say?
Take the most important numbers.
Yeah, take the highest, I spelled that wrong, highest in numerator over highest in denominator. And by highest, I mean highest powers. And look at those. Does that idea make sense? And based on what that relationship is, different things will happen. Just one more thing. Vertical lines, what are their equations? Is it x equals or y equals? Vertical are x equals. Horizontal are y equals. Okay. So this one, you can't simplify this at all, right? Don't cancel those x's. That's when you kill the kitty. So what number makes the denominator 0? 3. So there's a vertical asymptote at x equals 3. Now for horizontal asymptotes, you're looking at what happens as x gets really big, like infinities, like, well, millions, trillions. And all that matters there are these two highest powers. So you have 7x over x. Does that simplify at all? Yes, so it'd be y equals 7. So it means as you plug in really, really big numbers for x or really, really big negative numbers, your y values get close to 7. You can check it by plugging in like 1,000 in a calculator or plugging in like a million, and you're going to get something that's pretty much 7. Your calculator may even round it to 7 because eventually it's so close it's like indistinguishable. Okay, this one. So vertical asymptotes occur where the denominator is equal to 0. So let's just factor that denominator. How does that denominator factor? X plus 7, x minus 7. Great. And you can see that nothing's going to cancel the 3x plus 4, right? Okay, so this vertical asymptotes, it has two of them. They're at x equals what two numbers? Positive 7, negative 7. Those are two vertical lines your function will approach but never cross. Okay, now for horizontal asymptotes, you look at the 3x over x squared, which is the same as 3 over x, right? And think about what happens as you plug in huge numbers for x. What's 3 divided by a huge number?
0.
A small number, which makes 0. So this HA is y equals 0. That will happen whenever the degree in the denominator is bigger than the degree of the numerator. Does that make sense? Okay. Okay, how about this next one? VA. When does that denominator equal 0? X equals negative 1. Okay, then for the HA, you look at x cubed over x. That's just x squared, right? When you plug in big x's, does this approach a specific number? What happens to it? And it gets big. Does that make sense? So when you plug in big x's, this expression gets big. That means there is no horizontal asymptote. Okay. So in all of these questions, nothing actually simplified, like if you were to factor, nothing would cancel. This next one's a little bit different. We're going to talk about what happens with your picture when something does cancel. So does it make sense that the numerator in this problem has the greatest common factor of x? This is the same thing as x times x plus 2 over x. Does that make sense? And then what happens to those x's? They cancel, and you have x plus 2. Technically, you have to add in that x cannot equal 0. Where does that come from? The original equation. My Algebra 2 book in high school called that the restrictions on the function. Technically, you can't plug 0 in because in your original function, plugging in 0 is division by 0, okay? So that tells you that you're going to have a hole in your picture at the place when x equals 0, which is when it crosses the y-axis. So if you are to graph that line, where does it start? Y equals, this is y-intercept. 2. And you leave a hole there because technically that corresponds to plugging in 0, and you can't do that. Does that make sense where to leave holes? And then from that point, what do you do?
Draw diagonal.
Go up 1 over 1, because the slope is 1, or down 1 backwards 1. Anywho, there's your line. It's okay.
It's at 2, not negative 2.
It's at 2, not negative 2. Well, the y...
Why is the hole at 2? Not negative 1.
Well, y can't equal 0, so you go to the line, which is 0.
No, you said it wrong. Okay, so your line is x plus 2. If you had to graph that line with no restrictions, where would it start? How do you graph a line?
Oh, 2, 0.
Yeah, right, it's the y-intercept, yeah? Did you put it on the x-axis? That's how you would get negative 2. If you put that there, is that what you did?
I put x plus 2 is equal to 0, and then I subtract.
Oh, yeah. No. No, that finds something different. What does that find? That finds when your graph crosses the x-axis, which is at negative 2.
Oh, okay.
Right? But so you found that correctly. That's fine. You found the x-intercept. You just got to make sure you know what you're finding, not just like solving things blindly.
Yeah.
Otherwise, we're good. You could do that, and you could actually start at negative 2 and then just go rise 1, run 1 from there, as long as you know where to leave the hole. Okay. Whew, glad we figured that out. How about you guys factor and simplify the next one, eh? So when you simplify, does that x minus 5 come in the numerator, or does it stay in a denominator? Denominator. And what are the two things that x cannot equal? Plus 5 and minus 5. Okay. I'm going to just draw in a different color. That's the factor that gave plus 5. Does that make sense? The one that canceled, that's the one that corresponds to negative 5. Does that make sense? Which one of those is a vertical asymptote and which one of those is a hole? Let's see. Okay, so 5 came from the factor that didn't cancel, right? So 5 is a vertical asymptote. I meant to write hole for the other one. Which number came from the factor that canceled? That was negative 5. So hole at x equals negative 5. I think it's helpful to just draw in 2 vertical lines at both of them and just notate below them what they are. So there's a vertical asymptote. Here is a hole. And in this particular example, and actually two things. So in every example like this, you can plug the numbers into the simplified form. It will be easier. Otherwise, you're just gonna end up with cancellations that happen in your original function. It's silly, plug it in the simplified form. You're supposed to plug in a couple numbers on either side of that vertical asymptote, but I think I advise you try to pick whole numbers, and this one doesn't produce many whole numbers. Yeah.
So on the ones where it cancels and you end up with something just on the top or just on the bottom, there's no horizontal asymptotes.
This one will have a horizontal asymptote. I should have added that in, thanks. What will it be? It'll be y equals 0. Because you've got 1 divided by a big number minus 5. Does that make sense? So you have to think horizontal asymptotes mean x is a big number, right?
Yeah.
And if you plug in a big number here, you've got 1 divided by a big number minus 5. Well, big number minus 5 is still a big number, right? 1 over a big number makes 0. Okay. You could also do that by looking at the whole highest powers. You get the same conclusion, right? Because you have at 1 over x. Okay, so I'm going to choose to plug in 4, and I'm going to plug in 6. Those are the only numbers that are going to give you whole numbers here. So we'll just deal with it. When you plug in 4, what do you get?
-1.
-1. And when you plug in 6, you get +1. Does that make sense? Okay. What are you going to get when you plug in 7? This shouldn't be super hard.
2, 1/2.
1/2. So that's going to go like this. So over there, your picture is going to do this kind of thing. What would you get if you plugged in like 3? -1/2. So that tells you, there you go. And now how you deal with that place where there's a hole, I'm so sorry, can't connect my dots. You just draw your line approaching the x-axis and leave a hole when you cross that vertical line. That tells whoever's looking at your picture that you just can't plug that number in. The thing that I really wanted you to get, that you understand how you tell what are holes and how you tell what are vertical asymptotes. Does that part make sense? Okay. All right, we're going to do 4a. I'm actually going to skip 4b because I feel like you don't know enough math to do it well. So let's just do 4a. All right, is there any canceling that can happen? Can you factor in thing cancel? Okay, no canceling. Nope. So tell me, where is the vertical asymptote? VA at x equals 3. How about a horizontal asymptote? So y equals, y equals 3. You have 3x over x. Okay, so draw those in. 1 at x equals +3. 1 at y equals 3. And I know that what Alex requires you to do is you need to plug in 2 numbers on either side of that vertical asymptote. And so what'd you say, Tani? 2. 2 is a good number. When you plug in 2, you get 6 over positive or -1? -1. So that will be -6. So from the origin, go over 2 and down 6. Awesome. What's another good number to plug in? I like 0. When you plug in 0, you get 0 over -3. What's that? 0. So this picture goes through the origin. You've got 2 points. Draw something that approximately approaches those axes. Okay, how about on the other side? Plugging in 4 does come out nice, doesn't it? I think you get 12 over positive 1. It's way off my grid, so just draw me a dot up there someplace. It's another good number to plug in. 6? Yeah, 6 works well. With 6, you get 18 over 3, right? Which is 6. Okay, great. So 6, 6. For B, we're not going to actually graph it because I think you know more you need to know calculus to graph this thing really, really well. Let's just talk about what the vertical asymptotes would be, what the horizontal asymptotes would be, and if it's an even or odd function. Okay, we'll just do that much. So, vertical asymptotes. What are they if there are any? There's none. Yep. X squared plus 1 does not equal 0 for real numbers. How about the horizontal asymptotes? Y equals 0. Yep. Okay, and then even odd. How do you check for even and oddness? What do? You plug a specific thing in. You plug negative x in. So you have negative x over negative x squared plus 1, which is negative x over positive x squared plus 1, right? Okay. So is that, it's obviously not the original function, right? So it's not even. Is it the original function multiplied by negative 1?
Yes.
It actually is. And now this is tricky. If you multiply this thing by negative 1, that's negative 1 over 1. Only one of the numerator or denominator will change sign, not both. If both the numerator and denominator change sign, a negative over a negative makes a positive, right? So technically, this is negative your original function, which means it's odd. The picture, I'm pretty sure, looks approximately like this, but you've really got to know some more math to figure out like what those highest, lowest points are and stuff. So I think that's about what it looks like, but I don't think that's an appropriate question to ask you guys. And I got that question from your textbook, but I did not see it when I clicked through the Alex questions you were going to have. Okay, so don't worry too much about it. Alrighty, so far that's just review. The next thing, we're going to do 2 things that are new today. So the first thing is solving inequalities. So you solve inequalities with rational functions almost the same way as with regular functions. The thing is that you can't multiply stuff by 0 to get rid of it. That's going to change your answers. So when we solved this stuff for regular, like polynomials and stuff, we figured out where the expression was 0, right? Does that make sense? And we plotted those on number lines and made a sign chart, right? We're going to do something similar here, but you got to do 2 things. You got to first plot the zeros, and second thing you got to do is plot the vertical asymptotes. So your function can also change signs at those vertical asymptotes. Like those pictures that we've had, there've been like huge jumps at those VAs, right? So plot zeros, plot vertical asymptotes. And I think it would be useful to label what's what on your number line, because you're kind of liable to forget, at least I know I am. So first of all, what number will make your numerator 0?
6. I mean 2.
It's 2. Okay, shouldn't have put that on way so far over there. Let me erase that for a second. Okay, 2. So that is a 0. What number will make your denominator 0? 6. and then find the sign. So plug in some test points. What's a good test point to the left of 2? 0. And when you input 0, what is the sign of your numerator? So it'd be plus over minus, which makes a negative. What's a good test number between 2 and 6? 4, sure. Whatever number you pick, your conclusion about the sign will be the same. So if you plug in 4, your numerator is negative 4 plus 2, which is a positive or negative number. Negative. Your denominator is 4 minus 6, that's negative. A negative over a negative makes a positive. And then past 6, pick something like, say, 7. Okay, so if you plug in 7, is your numerator positive or negative?
I mean, no, it's talking about denominator.
I know you keep mixing them up. So the numerator is negative, the denominator is positive. So overall your function is negative. Is everyone okay with how I found the signs? Okay, everyone else okay with what numbers got plotted on the axis there? Okay. So now you have to figure out, you are looking for where that expression is less than or equal to 0. So you're looking for the negative parts or positive parts? Negative parts. Okay. So, and the or equal to 0 means that you include numbers where the thing is equal to 0, right? So that means your answer is negative infinity to 2, and you include 2 because your function is 0 there. Do you include 6?
No.
No, because your function is undefined there. Does that make sense? So you go from negative infinity to 2, union parenthesis, 6 to infinity.
Wait, why don't you include 6?
I should have labeled what it was. 6 is a vertical asymptote.
Oh,
Does that make sense? So you can't plug it in no matter what. That's why I think it's helpful, and I did it for the first number and didn't do it for the second number, to label that 1's a 0, as in the function, the expression equals 0 there, and 1's a vertical asymptote, and so you can't plug that in, it will never be included. Okay, is everyone all right with that? All right. So the previous one said 0, this one says less than or equal to 2, right? I just know how to deal with 0. So a lot of things in math involving taking something that you know, something you don't know and making it something you do know. Does that idea make sense? So what you can do is take away 2, right? Make this into 4 over x plus 5 minus 2 is less than or equal to 0. Woo, I got 0. Yeah. Now crap. Now what? You need to have it be one rational expression. So what could you do to make those be written as one fraction? Common denominator. X plus 5 over x plus 5. I don't put too many parentheses there, so sorry guys, just ignore me. Does that make sense? So that's 4 minus 2x minus 10 all over x plus 5 less than or equal to 0. Be really careful with your negative signs because that's a place that you could probably mess up, right? Do you agree there? Okay, so how does that simplify a little bit more? Your numerator is negative 2x minus 6. Great. Over x plus 5. Do you agree that now it's more or less the exact same as the previous one we did once we've done manipulated it so it looks like this? Okay. So when is this thing 0? Negative 2x minus 6 equals 0. When does that happen? Negative 2x equals 6, x equals negative 3. Okay. And when is the vertical asymptote?
Negative 5.
Or, yep, negative 5. Okay. So negative 5. You could put VA or you could put undefined. test the signs.
So you put, it's an undefined vertical asymptote? Is that what you put?
Being undefined and so it's a technical thing where I'm just being a little picky with myself, but it's only a vertical asymptote if you have like a y equals and there's no y equals going on here, like we're not necessarily talking about the graph, but it does correspond to that, so don't worry about it too much. But it's the function, the expression is undefined there.
Okay, so when I was looking for the vertical asymptote in the equation, it looked like it would be negative 2x over x, and then you would get y equals.
That's the horizontal asymptote.
Oh, that's right, okay.
Yep. Okay. Test number to the left of -5. -6. Okay, if you plug in -6, you get, in the numerator, you get 12, right? Minus 6, which is,
Positive.
and the denominator is
-1.
negative. So overall, your expression is negative there. What's a good test number between -5 and -3? -4. The numerator's sign is, and the denominator's sign is plus. So plus. What's a good test number past -3? 0. Numerator's sign is minus, denominator's sign is plus, so overall we're minus there. Okay, now look back at what you're trying to solve. Are you looking for where this expression is negative or where this expression is positive? Where it's negative. Okay, so obviously negative infinity up to -5. First decision is, do you include -5 or not? No. Okay, decision made. And you don't include it because it's asymptote / undefined. Okay, union. When do you start again?
3.
And do you include that one?
Yes.
Yes. To infinity. Awesome. So they're a little tedious because the whole getting a common denominator thing can be like a pain in the butt, right? But other than that, it's the same sort of sign idea as before. Does that make sense? Okay. Okay, here's how I did this one. What would you think if you saw this? What would you think to try? Subtract x and 1? Okay, so 0 is less than 5x minus 3 over x minus 3, sorry. Minus, let's just say minus the whole x plus 1. Does that make sense? Okay, now that you've done that, what do you have to do? Common denominator. So that x plus 1 is over 1. Multiply it by x minus 3 over x minus 3. So multiply them together, simplify, see if you can get it. Did you get x squared minus 2x minus 3? At least eventually? Okay. Now the really tricky thing here, because of how you chose to do this, and also is how I chose to do it, is that negative that technically is in parentheses, the fraction bar acts like a parenthesis, so that negative is going to distribute when you combine the numerators. So you've got 5x minus 3 minus x squared plus 2x plus 3 over x minus 3. The devil's in those stupid details. Does that make sense what happened though? All right. And some nice stuff happens, as in like the 3's cancel, don't they? So I think you just have negative x squared plus 7x, is that right? Over x minus 3. Okay. So first, find the zeros. So figure out where negative x squared plus 7x equals 0. Notice how that pretty much is like if you had an equation or even if you had a function y equals that stuff, if you find the x-intercepts, right? It's the same technique. How do you solve that equation? This one gave you a little trouble in your test. There's a GCF, greatest common factor. What is it? X. So x times parenthesis, negative x plus 7. So what are the zeros? And great. And where is our undefined / vertical asymptote place? X equals 3. Okay, so now make your number line. On there we have 0 first, 3 next, and then 7. And shoot, I can't plug in 0. And remember, when you're plugging them in to look at the sign, you're looking at this guy. So what's a good test number to the left of 0? -1. Okay, what's the denominator's sign at -1? Negative. I held off on the numerator on purpose. It's a little bit more tricky. When you plug in -1 into the squared, first you square it, right? Which makes it,
Positive.
and then you negate it, which makes it negative. So your numerator is going to actually be negative. It's also negative because of the whole 7 times -1 business. So a negative over a negative makes a positive. Okay, let's plug in, how about 1? If you plug in 1, what sign is the denominator? Negative. How about the numerator? Positive. Yep, I buy that. So overall, your expression is negative. Okay. How about test number here? 4, sure. So in your numerator, if you plug in 4, you get -16 plus, it's 4 times 7, 28, right? So that's, denominator is also plus, overall you're plus. Okay, and how about past 7? Like 8. You have -64 plus 56. That'd be -64 plus 56. That's definitely negative. Denominator would be positive. Overall, you are negative. Okay, so which part are we looking for? We're looking for the negative part or positive part? Negative. Are we looking for where, oh, and let's label these things. So 0's a VA / undefined. No, it's not. I said it's wrong. What is 0? 0's a 0. How about 3? VA. How about 7? 0. Okay. We don't need to do that for these because this time you're looking for the expression that's strictly bigger than 0. So there's no equal to on it. Does that make sense? Okay, so we're looking for the positive parts or negative parts this time? Positive. So we have -infinity up to 0, and we don't include 0 because we're not looking for where this expression is 0. And what else? 3 to 7, yep. Okay. Woo, tedium. So sorry. Yeah. You gotta talk louder. I'm sorry, so sorry, I can't hear you, okay?
Sorry, I think I missed one of them, never mind.
Okay, you're good? All right, ready for the next one? Because overall you were positive there.
And we're looking for ones where it's.
Because you see, you're looking for where this expression is bigger than 0, right? The 0 is not getting eaten, which means the other stuff has to be positive. With the next one, I would suggest taking away 6 over x. It's a little bit easier. So start with that, get a common denominator. Can I go to the next one, Tani?
Yeah.
Okay, great. So I have 0 bigger than or equal to negative 6 over x plus 1. So how might you get a common denominator?
Times everything by
Except for the first one, right? Yep. X over x and x over x. And that's 0 is bigger than or equal to negative 6 over x plus x squared over x plus x over x. Is everyone okay with what happened there?
Would it be wrong to multiply by negative in the beginning?
I had that thought myself, and I'm afraid I didn't have time to actually check it out. I think that one slight problem is that you don't know the sign of x, and so x could be a negative number, which would flip the inequality on you. Does that make sense?
Yeah.
So I think that probably best not. But I had the same impression myself, as Mark makes you feel better. Okay. Okay, now let's factor that numerator. So how does that numerator factor? X plus 3, x minus 2, all over x. Awesome. Okay. All right. So what's the first 0?
negative 3.
Negative 3. What's the other one? 2. And where is my expression undefined? 0. Okay. Okay, let's pick some test numbers. So good test number on the left of negative 3. Negative 4, negative 6 also works. I mean, anything more negative than negative 3. So you plug negative 4, and look at this factored stuff. That's actually the easiest way. When you plug negative 4 in, what is the sign of the first factor in the numerator? Negative. Second factor?
Negative.
Negative. Denominator factor? Negative. Overall, we are
Negative.
negative. Okay, negative 2. First factor? Second factor? Denominator? Negative. Overall, we're positive. 1. Positive, right? Negative over positive? Overall, you are negative there. And then how about 3? Plus, right? Plus and plus. So, plus. All right, so the alligator, because for me inequalities are alligators, is eating the 0, right? Which means 0 is the bigger thing, right? And if 0 is the bigger thing, what are we looking for, positives or negatives here? Negatives. So we'll have the solution is negative infinity up to negative 3. Do you include negative 3 this time?
Oh, yes, you do.
Yes, you do. Okay, union. Do you include 0?
No.
Nope. Do you include 2?
Yes.
Yes. If that inequality did not have an or equal to on it, what would be different? What would you disinclude?
Your brackets would be
The negative 3 and the 2, right? They'd be parentheses. Okay. So I think that's not super, it's tedious, it's not ridiculously hard. Let's do one more. So which way do you want to solve this one? Do you want to move the 2 over x plus 3 over? Or do you want to move the 1 over x plus 1 over? Do you care?
I'd say 1 over x plus 1.
Okay, I think that's a good idea. I think that works better. So 2 over x plus 3 minus 1 over x plus 1. I'm leaving space because I know I'm going to get a common denominator. Like, I know that's my next step. Is everyone okay with what happened there? All right, to find a common denominator, what do you multiply the first fraction by?
X plus 1.
How about the second one? Okay, so we'll have 2x plus 2 minus x minus 3 over our common denominator of x plus 3, x plus 1. Is it clear why I have 2 subtraction signs in the x and the 3? Okay. So combine them now, and we have, what does your numerator simplify to? Very good. X minus 1 over x plus 3, x plus 1 is less than 0. Okay. So where are your zeros? Say that again? Yep, 1. Where are your undefined points? Okay, great. Now plug some numbers in. Okay, so to the left of -3, we're going to test.
-4.
Numerator is negative, denominator is negative times another negative, right? So overall your expression is negative there. We get a negative over a positive times a negative. Overall your positive there. What's a good test number between -1 and +1?
Good old 0.
We love 0. Yay. Numerator, negative, denominator is 2 positives, right? So overall you are negative there. And like, I don't know, 2. Numerator positive, denominator plus plus, we're going to be plus. Okay, so are we looking for the negative bits or positive bits?
Negative.
Negative. Okay, so we have negative infinity. Do we include -3? No. Okay, union. Do we include -1? No. Do we include +1? Also no. Does that make sense? But for a different reason. The reason we don't include -3 and -1 is the expression's undefined there, right? What's the reason we don't include 1?
Equation.
The inequality didn't have an or equal to on it, okay? So there you go. So the general rule of thumb with inequalities, kids, is that you always have to use number lines unless they're linear. Does that make sense? So it's trickier because of the whole sign flip-flopping. Like you said, multiplying by x could change the sign around. Okay, the last thing actually won't take very long, so I think we can do it in a little bit. So sometimes functions will have what are called slant asymptotes, which means that as you plug in big numbers, your function like approaches a diagonal line of some sorts. And it turns out that this happens when your numerator's degree is exactly 1 more than your denominators. And how you find the line that your function approaches is use long division. We're not done yet. So take this and we're going to do the long division. So the x plus minus 2 is going to divide into the x squared minus 3x minus 4. Long division will definitely be on your test, so you should know how to do it. what do you multiply x by to make it match that x squared? X. So you've got x squared minus 2x. Take away, be careful with your signs. What's negative 3x minus negative 2x? Negative 1x. Okay. And now what do you multiply x by to make it match the negative 1x? Negative 1. Negative 1x plus 2. Take away, what's your remainder? Negative 6. So you can rewrite f of x as x minus 1 minus 6 over x minus 2. Does that make sense? This is your quotient, right? And it's remainder over divisor. Now think about what happens as x goes to infinity, let's say. So as x gets big, where does the 6 over x minus 2 approach? 0. So that means when you plug in bigger and bigger numbers, you're getting closer and closer to the x minus 1. X minus 1 is a line, right? So your slant asymptote is y equals x minus 1. So that's the line that you approach. And so if you were to draw it in, you'd say, oh, I'd plot x equals minus x minus 1 by going down 1 and a slope 1. You'd know as you plugged in big x's, your picture approached that line. But it's always going to be that what you approach is the quotient part.
So we won't need really look at
The other part does actually have to be like a number over a thing with an x to officially go to 0, but as long as you have the numerator's degree is 1 more than the denominators, that will always happen. Okay? Let's try the next one. So do the long division. So x plus 1 going into x squared, I'm going to put in a 0x plus 5. So what do you multiply x plus 1 by to make it match that x squared? X squared plus x. Take it away. All right, do you get positive or negative there? Negative. Okay. Negative x plus 5. Okay. Then what do you multiply x by to make it match the negative x? Negative 1. Negative x minus 1. Take it away, your remainder is 6, I think, right? Because the double negative business, right? It's okay. So your original f of x is x minus 1 plus 6 over x plus 1. If you ever wanted to check that, you could get a common denominator, and that should check out to be what you had in the beginning. So what is your slant asymptote going to be? What line?
Y equals x minus 1.
Yeah, the answer isn't always x minus 1. It just happened to be a coincidence that I did that twice. And we are going to do example 10 because this one doesn't take very long. So, is everyone okay with how you find the slant asymptotes? Okay. So example 10 says find all vertical, horizontal, and oblique. Oblique is another word for slant, okay? So vertical asymptote is where x cubed minus 8 equals 0. That means x cubed equals 8. So what number is there a VA? 2. Okay. HA. Look at biggest power over biggest power. If you simplify that, you're going to get x squared, right? So there are going to be none. Slant, because spelling is not my thing, and oblique is not going to happen at 8:55 in the morning. So for slant, you have to have that the numerator's degree is exactly 1 more than the denominators. This numerator's degree is 2 more than the denominators. Does that make sense? So there are also none. So no HA, no slant. Okay, how about this one? Is there a vertical asymptote? I think there is. A VA there is. x equals 0. Right?
Yeah.
Okay. How about HA? Any horizontal asymptotes? Officially no, because the numerator's degree is more than the denominator's. Okay, for the slanty people, this one, when you're dividing by a monomial, so monomial means it has one term, the division's actually really easy. You can just take every single piece and put every single piece over x. Do you understand that what you did there is you kind of uncombined the common denominator? That idea of doing it this way will come up again in calculus, okay? So it's not like me being special. And then simplify all the pieces that simplify. Does the first piece simplify?
Yes.
Does the second piece simplify?
Yes.
Last piece? No. Which part of that is your slant asymptote? Negative 3x plus 5, yep. This part, right? You could do long division if you wanted to, but on that kind of thing, you don't have to, and it's good to know that shortcut because that idea is going to come up again.